In this video, I am going to find the inverse of this function f of x is equal to square root of x minus 7 for x greater than or equal to 7, and show that the new function I found is in fact the inverse of the given function by doing function composition. To find the inverse of a function, we follow a standard process. The process involves setting the given function to y and solving for x. So we will have y is equal to square root of x minus 7. Now we need to solve for x. To solve for x, we square both sides of this equation. So on the left we are going to get y square is equal to, on the right side, square and square root are going to cancel out. That's going to give me x minus 7 on the right. Then I add 7 to both sides to get y square plus 7 on the left, and on the right just x, because positive 7, negative 7 cancel out. Now I would need to switch the x's and y's basically. So I'll just rewrite this. We have x is equal to y square plus 7. Now I'm going to switch the x's and y's, meaning this is going to be my y, new y, and this is going to be my new x. If I do that, I'm going to have y is equal to x square plus 7. Now I call this function y is equal to x square plus 7 my new function, or the inverse function of this given one. So my f inverse of x is equal to x square plus 7. My claim is that this function I just found is in fact the inverse of this function. Now how do I show that? For showing that, we have a standard process which involves finding function composition. So what we will do, we will find f composed with f inverse of x, okay, which is gonna give me x, and then compose it the other way, f inverse composed with f of x, that should give me x. So regardless of the direction of the composition, I should get x. If that is the case, then this new function that I got is in fact the inverse of the given function. So let's do the first one, f inverse composed with f of x, okay? I mean f composed with f inverse of x, f composed with f inverse of x. By definition, this is going to be f of f inverse of x. Now this is the function that's going as an input to f. Now we already found f inverse. What is my f inverse? Which is, by the way, this x square plus 7. So I'm going to take this x square plus 7 and put it here. Now this x square plus 7 is going to go into f as an input, like input x. So this is going as an x value. Think of x square plus 7 as one unit, single unit, like an x, okay, going in there. So what does the function f do to its input? It subtracts 7 from it and then takes the square root of the result. Once again, it subtracts 7 from the input is x, from that is going to subtract 7 and take the square root of the whole thing. It's going to do the exact same thing. So from the input is going to subtract 7, so it's going to be x square plus 7. From this, remember this is the input, from this is going to subtract 7 and take the square root of the entire thing. Now positive 7, negative 7 is going to cancel out. That's going to give me just square root of x square. Now square and square root are going to cancel out. That's going to give me just x. So f composed with f inverse of x is equal to x. That checks. Now I'm going to do the composition the other way. F inverse composed with f of x, which by definition is f inverse of f of x. Now remember, this f of x goes into f inverse as an input. So f inverse of f of x, we know what is f of x, which is this, right? Square root of x minus 7. Now this square root of x minus 7 is single thing, like an input here, okay, x going into f inverse. Now what does f inverse do to its input? The value that's going into the function is going to take that value and square it as it does here, and then add 7 to it. Once again, it's going to take this value that's going into the function, is going to square it and add 7 to it. Now it's going to do the exact same thing, however it's going to do it to square root of x minus 7. Square root of x minus 7, that's the input, is going to square it and then is going to add 7 to it. Now square and square root is going to cancel out. That's going to give you x minus 7, then plus 7, which is going to give you 7 and 7, negative 7 cancel out. That's going to give you just x. So it turns out that in the other direction, f inverse composed with f of x, I still get x. So the function I found here is in fact the inverse of the given function f of x. Now I need to show something else about the behavior of this function, which is going to be more visual and is going to help you see what's happening. I have sketched here both f of x, which is this one, and f inverse of x, and the line y is equal to x. It's a sketch, so it's not perfect, but you will get the idea. That's the most important part. This function is a mirror image of this function about the line y is equal to x. So this one, if this white dotted line were to be a mirror, if you put this function here inside the mirror, you will see the reflection, which would be this. On the other hand, if the mirror is facing this way, then if you have this function in front of the mirror, inside you will see this function. So the basic idea is that if two functions are inverses of each other, they are mirror images of each other about the line y is equal to x, which is the line, by the way, that goes right through the middle right here, okay, makes a 45-degree angle. So that's what it is. Now let me summarize what I talked about in this video. I talked about how to find the inverse of a given function by setting it equal to y and solving for x and then switching the x's and y's to get the inverse function. Now we show that this function is in fact the inverse by finding function composition f composed with f inverse of x and showing that that is equal to x, and by finding f inverse composed with f of x and showing that that is also equal to x. Basically, regardless of the direction of composition, you should always get x, which I did show here. Now finally, I showed it to you graphically that two functions, if they are inverses of each other, they are going to be reflections of each other about the line y is equal to x, or they are mirror images of each other about the line y is equal to x. I hope that this discussion was helpful. Thank you very much.